Hey guys, so for my discussion post, I was going to do given KEQ and initial concentrations, calculate the unknown concentrations. I was going to show myself doing it, but my camera flips everything. Give you guys a first person view. So to start out, we're gonna be given some things. Some things given is like the KEQ, which is unitless, and for this problem, it's going to be KEQ equals about 360. We're also given the concentration of CO, which equals 0.17 molal, and CH3OH equals 0.055. Things that we need to know is, like, of course, the balanced equation. The balanced equation is going to be CO plus 2H2 yields CH3OH. And something that we're going to need to know is that KEQ equals your product's concentration over your reactant's concentration. So if I'm going to rewrite this, let me turn it. It's going to equal your concentration of CH3OH over the concentration of CO times the concentration of H2. But something that we should notice is that to balance the equation, we need 2 H2s per every CO. So because of that, we're going to square H2 on this side. Now, we are given the concentration of CO and CH3OH, as well as KEQ. So now we can rewrite this as KEQ, or 360. It's going to equal the concentration of CH3O, which is that 0.055 divided by the concentration of CO, which is 0.17 times H2 squared. We don't know what H2 is, so I'm just going to put an X here, and I got to remember to square it. So at this point, so we're looking for X, and we basically have our entire equation. So what I can do for this now is 360 times 0.17 divided by 0.055. It's going to equal 1 over X squared. So what I can do here is I can flip the entire equation and then take the square root. So that's going to be 0.055 divided by 360 times 0.17. Take all this and square root it. That'll get you your concentration. And basically it's just math from there. I wasn't sure if I was supposed to show you guys an ice table. So this was another problem that I was going to show you guys. Is it shows 2 IBR is going to yield BR2 and plus I2. Of course, the first thing we have to do is balance the equation. So there's 2 IBR for every 2 BR2, or for every 2 BRs and every 2 Is. We are given that the initial concentration of IBR is 6.5 molal, and to start, our products don't have any concentration. It's just straight 0 for both. So that's why I put in the initial concentration is 6.5, whereas BR2 and I2 are 0. Now, for an ice table, I stands for initial, C stands for change. For this reaction, IBR can only go down, and BR2 and I2 can only go up. So what I'm going to do is I'm going to put a plus, if I could, plus on both sides to show that BR2 and I2 are like receiving more concentration, whereas IBR is only losing concentration. We also have to take into account that it's 2 IBR for every BR2 plus I2. So it's a ratio where we have to double the concentration. So that's why there's a minus 2x, because of that coefficient in front. And so I don't know the concentrations of BR2 and I2, so I'm just going to put an X here. So at the end, our equilibrium should be Whoa, I'll try to get in frame. Oop, nope. 6.5 minus 2x. And this is going to be just x. This is also just going to be x. So if I want to write my KEQ for this one, I'm going to have to, it's products over reactants. So my KEQ is going to equal my products, which on the other side is just x squared, over my reactants, which is 6.5 minus 2x. And then from there, if I was given KEQ, I can solve. Also, if I was given the concentration of either Br2 or I2, I can also solve the KEQ for that. And that is it. Thank you.